Hello everyone and welcome back to the channel. Today we are discussing the first practice problem for this series and we are discussing Leetcode problem 2007, find original array from doubled array. So let's quickly go through the problem statement. So first the problem statement defines that what do we actually mean by doubled array. So an integer array original is transformed into a double array changed by appending twice the value of every element in original and then randomly shuffling the resulting array. So what the problem statement is trying to say is that we have an integer array called original. So we pick each element of this original array one by one. We take the double of this element and we append the double value to the to the same array itself. And once we have done this for all the elements, we'll have a even sized array containing the original elements and the double of these elements. So now this resultant array is randomly shuffled and subsequently the result that we receive or the resultant array is called the double array or it is named as changed. So now we have been given an array changed. Return original if changed is double array. If changed is not a double array, return an empty array. So in the problem we get an input array which is actually the changed array. Now what we need to do is we need to check that if it is a legit doubled array. If it is not a doubled array, then we need to return an empty array. But if it is a legit array, we actually have to find out the original array which was used to create this double array and we need to return that original array. So what are the few important things that we need to keep in mind about this doubled array? So first important thing is that the size of this array needs to be even because they are going to be original elements and they are going to be the double of these original elements. So definitely the size is going to be even and we should be able to break this array into two sets. So if I say take these two sets, the first set is going to be the original values and the second set is going to be double of these values. So we should be able to create a one-to-one mapping between all the elements of both the sets. So if we are able to create or we are able to find a one-to-one mapping between all the elements of both the sets, then definitely it is a legit doubled array and what we have to do is we have to actually return this original set. Now the very core logic of solving this problem is really easy. So what we need to do is that we need to check that if we have an element, we need to check whether the array contains the double of this element or the half of this element. If the array contains the double or half of this element, then we can pair this element with the double or the half and thus we get one map. If we are able to complete this process for all the elements of the array, then we'll get all the mappings and in each pair the smaller value will be added to the resultant or the answer array and we'll return that array. So what could be a technique to actually implement this logic? So let's take an example and try to dry run on that would be much easier. So take an example 1 3 6 12 2 24. So what we'll do here is that we'll start traversing from the starting and we'll keep a set. We'll have a set of numbers that we have already visited. And in this set, when we are at any element, we'll try to check if this set contains the double or half of this element. If this set contains the double or half of this element, then we'll pair those two elements. Now obviously since we are keeping track of the elements that we have already visited and we need to add elements and search elements in this set in the most optimal manner possible and even delete elements from this set in the most optimal manner possible. And obviously if we have to keep track of the elements and do insertion, search and deletion from our data structure in the most optimal manner, it obviously makes sense to use a map or a set data structure. So here we are going to use a set data structure. So let's quickly dry run through this example. So we are at 1 and we know that the set is empty, so we cannot find the double or half of 1, so we'll add 1 to this set. Now we'll come at 3. Again the set does not contain the double or half, so we'll add 3 to this set. Now we'll come at 6. Again we'll try to search the half or double of 6. So the half of 6 is already there, so we'll remove 3 from our set, and we have found one pair which is 3 comma 6. Now we'll come at 12. So again 12 will be inserted into the set because 6 or 24 is not there. Then we'll come at 2. So 2 and 1 will get paired, so 1 will get removed from the set, and we have found another pair which is 1 comma 2. Now we'll come at 24 and we'll see that 12 is already there, so again we'll be able to pair 12 and 24. Now these are the sets, or these are the mappings that we have got, and obviously the original array is going to be the smaller element from all the mappings or all the pairs. So the original array is going to be 1, 3 and 12. So we'll return this original array. So the core logic is really simple to implement and understand, but there's a very trivial problem with this logic. So for instance, let's assume that our array would have been something like this. Now let's try to dry run our logic or implementation on this particular example. So when we are at 3, obviously 3 will be added to the set. Then we are at 12, 12 will be added to the set because 6 or 24 are not there in the set. When we come at 6, here we'll find that we have two options for 6. So we have 3 and we also have 12. Now it'll be really difficult to decide that whether we need to pick 12 or whether we need to pick 3, because in this case we know that we need to pick 3, because if we pick 12, then 24 and 3 would not be paired in any way. There would be no mapping between 3 and 24, and we'll say that it is not a doubled array, which is not true, because 3 and 6 should be paired and 12 and 24 should be paired. So when we are at 6, we have actually so when we are at 6, we actually face this problem that which element should we pick to form the pair. So this is one scenario or example in which our implementation will fail. There are other scenarios or other conditions as well. So for instance, if we have an example array 2 comma 4 comma 1 comma 8, in this we'll see that we'll add 2 to the set. Then when we come at 4, we'll actually pair 2 and 4 here, because we'll try to find the half or double of 4, and we'll see that the half exists, so we'll pair these two. When we come at 1, we'll see the set is actually empty, so we'll add 1 there, and then we'll come at 8 and we'll see that again 8, there will be no possible pairing for 8, and 1 will also be left unpaired. And after that we'll say that this is not a legit doubled array, and we'll return an empty array. But if we see, actually this is a legit doubled array, and the original array for this doubled array should be 1 comma 4, because there's a pairing between 4 and 8, and there's a pairing between 1 and 2. So now let's try to understand that how we are going to mitigate this problem. So from our example, it seems that it is really important to understand that in which order we need to parse these elements, or in which order we need to process these elements. So let's try to understand a simpler logic. So let's say that we have an array ARR, which is the input array or the doubled array. Now when we pick the smallest element from this array, let's say that the smallest element is A. So A has only one option. It can be paired with 2 into A. Because A is the smallest element of this complete array, there's no possibility that we'll find A by 2. So definitely A needs to be paired with 2A. Now let's pick up the second smallest element of this array. Let's say that the second smallest element is B. Now what options does B have? Either B will be double of A, so either B is going to be twice into A. So if that is the case, then A and B should definitely be paired, because if we are not going to pair B with A, then A will be left unpaired, because A by 2 is definitely not going to be there in the set, and we need 2A. And if B is 2A, then definitely A and B needs to be paired, because A and 2A needs to be paired. So if B is equal to 2A, definitely it will be paired with A, and that's how A will find its pair. But what if B is not equal to 2A? If B is not equal to 2A, so this is the case when B is equal to A, But what if b is not equal to 2a? If b is not equal to 2a, then b also has only one option, because b is not equal to 2a and b is the second smallest element. So if we try to find b by 2 in this particular array, we are never going to find b by 2, because the only element smaller than b is a, and a is definitely not equal to b by 2, because b is not equal to 2a, then so a is not equal to b by 2. So b, in this case, b also has just one option, that we would have to find 2 into b. B can only be paired with 2 into b. So again, like a, b will only have one option. Now if we try to pick up the third smallest element, we'll see that the same logic continues, and we'll be able to extend this logic to all the elements. So by this logic, we conclude that it actually makes sense to pick up elements or to process elements in sorted order, because when we are processing elements in the sorted order, it kind of creates an ordering between them, in the sense that out of the two possibilities for an element, so the two possibilities for an element is by 2 and into 2. So out of these two possibilities, this by 2 possibility is definitely going to exist on the left side of this element. We will definitely not find this by 2 possibility on the right side, and the into 2 possibility exists only on the right side of the element. We are not going to find into 2 possibility on the left side. So if we process these elements in the sorted order, we'll be able to solve our problem of which element needs to be paired with which element. So let's try to dry run our approach on this particular example. So first, as we have discussed, we'll sort this particular array. So after sorting, this array would look something like this. Now let's try to apply our logic on this particular array. So this is our set. So when we are at 1, we see that the by 2 of 1, which is 0.5 or 0, does not exist in this set. So definitely the only possibility for 1 is to get paired with 2 if it exists in the set. So we'll add it to the set 1 and wait for its double to come, and then we'll pair 1 with its double. Then we come at 2. Now when we come at 2, we see that the half of 2 actually already exists in the set, and we have no choice but to pair 1 and 2, because if we'll not pair 2 with 1, then 1 will be left unpaired, because 1 does not have any other option. So the only option we are left with is to pair 1 and 2. So we'll extract 1 from this set and create a pair for 1 and 2. So we have created one pair. Now we'll come at 4. So the set is empty, 4 has no option, so it will go into the set. Then we'll come at 8. So again we have half of 8 existing in the set 4, and we have to pair these two elements because 4 does not have any other option but to get paired with 8. So the next pair that we are going to make is going to be 4 comma 8, and the array that we are going to return is going to be 1 comma 2, sorry, 1 comma 4, the smaller element from each pair. So as we can see that our sorting logic actually worked, and now our core logic or the original implementation will give the correct answer. Now let's quickly discuss the code for the solution that we just discussed. So find original array is the method that has been given, and we need to complete this method. So the method takes as input the changed vector. So this vector contains the original values and the doubled values in a shuffled order, and we need to return the original vector for this changed vector. Now, as we have already discussed that we'll process this vector in a sorted order. So as a first step, we have sorted this input array. Now in our solution, we discussed that we will be using a set, but instead of a set, we have actually used an unordered map here. So what was the reason for using a map? So in the cases that we discussed, each value was distinct. So in this case, each value is distinct and we can keep a track of each value using a set. But in the problem, nowhere it is specified that all the values in the input vector are going to be unique. So they can be similar as well. So for a case where we have values something like this, the set wouldn't actually work, because in the set we can only keep the value, but in the map we also need to maintain the frequency of each element. So in the map we need to keep a track of how many elements have been paired and how many elements are still left. So for instance, if we would have input array something like this, and till here in the map we are storing the element versus its frequency. So the entry in map would look something like this, 1 comma 4. Now when we come at 2, we know that we can use one of these ones to actually pair it with 2, and we can reduce this frequency of available ones to 3 and create a pair for 1 and 2. So we have actually used one of these ones, and still we are left with 3 ones. So in order to keep a track of how many elements we are left with and how many elements we have tracked till now, we actually need to store a pair of value versus its frequency. And for this purpose we are actually using a map instead of a set, and each entry in map is going, and as we know that each entry in map is of the form key value format. So the key here is going to be the element or the value that we find in the array, and the value against it is going to be its frequency. So for this use case we are actually using a map instead of a set. Now in the next line of our code, which is line number 6, we have actually declared an array, so, or a vector. So this vector is going to actually store the final answer that we have to return, or in this case the original array which was used to make this changed vector. Now we start our actual code from here till here. So in this loop what we are doing, as we discussed, the input array has already been sorted, and now we'll be processing each element one by one in the sorted order. So we are picking each element one by one. So in the first condition we are checking that if there exists a half of this number, if we have already encountered the half of this current element, then we can pair those two elements. Now the first thing we are checking in this condition is that the current element should be even. So if this element is actually a double of any value, it definitely has to be even, it cannot be odd. And why this check is necessary? Because if we do not check that this is even and say it is a odd number like 3, now during our computation we would do something like 3 by 2, because we have to find the half of this current element, and that's why we'll divide it by 2. Now this would return 1, and there might be a case that we actually have 1 in this map and 1 and 3 will get paired, which is not correct. So we need to make sure that our current element is actually even. Now in the next two conditions what we are trying to do is, first we are trying to find whether in this map we have the half of this current element. So the find method is the predefined method which we use to find whether this key exists in our map or not. If this key exists in our map, then the iterator pointing to that key will be returned, otherwise the end pointer will be returned. So we are just checking that the pointer returned by find method should not be equal to end. If it's not equal to end, then definitely this key exists in our map. And the second thing we are checking is that if this key exists in the map, the frequency against this key should be greater than 0, because there should be leftovers, or there should be remaining amount of this element that we can use. If the frequency against this particular key is 0, that implies that we have already used all occurrences of this particular element to pair it with some other elements. So now if we find this value in the map and we have some leftovers, then what we'll do, we'll pair the current element and this value. So first thing is, what we do, we reduce the leftover frequency, so we reduce it by 1. Now one thing what we are doing here is that if we have reduced the frequency, and if the frequency reduces to 0, we are actually removing it from the map. So it makes sense that we do not need to keep an element in the map if the frequency is 0 against it, and which implies that we have already used all the occurrences of this element. That would only increase the overhead next time when we are searching. So what we are doing here is that we are actually deleting this key from the map altogether if the frequency of this element reduces to 0. And finally we are pushing num by 2 in the answer, because the current element num is present in our changed array, and num actually came from num by 2. When num by 2 was doubled, num was introduced in the change array and then it was shuffled. So actually num by 2 was definitely present in the original array which gave birth to num. So num by 2 needs to be added to our original array, so we have pushed it into our answer. Now in the case that we did not find the half of the current value, so in the case where num by 2 was not present in our map, that implies that num was actually present in the original array itself, or num was used to create another element that we are going to encounter further. So it might be the case that num does not give birth to any further element. In that case, this is a wrong changed array, this is not a legit changed array, and we should return an empty array, or the num would have been used to give birth to some other element which we are going to encounter further, since we are accessing elements in a sorted order. So in that case, we just add num to our map and increase the frequency against num by 1, and we'll see if somehow in future we'll get 2 into num, so then this num will be added to the answer array. But in the case where 2 into num would not be present in our array in the future, in that case this is a case where an empty array needs to be written, because this is not a legit doubled array. So when we are done with this processing, we need to make sure that the size of our map is 0. We need to make it sure because all the elements should have been used to give birth to some other element, or all the elements should have been half of some other element. If there are some elements left in the map, that implies that these elements were not used up and these were not actually half of some element. And in that case, the doubled array which has been given to us is not a legit array, it's a wrong array. So in that case, as defined in the question, we'll return an empty answer. But in the case when the size of the map is finally 0, all elements were used up, it implies that it was a legit changed array, and the answer array that we have created till now is actually the original array, so we'll just return that original array. Now let's quickly discuss the time complexity for this solution. So first thing that we do in our solution is sorting, and sorting in best case is going to take n log n time. In the next heavy step is our loop, where we are adding elements to the map, removing elements to the map, and searching the elements in the map. So in the worst case, we are going to traverse all the n elements in the array, and all these n elements will be added to the map, and we'll search n times in the map. So insertion and searching in map is actually going to take O1 time. So if we are going to do these things n times, the total time complexity for this loop is going to be big O of n. So the final time complexity for this solution is going to be big O of n log n, which is actually the complexity of sorting. So I hope that you understood this problem and the solution specifically, and how we use maps and sets to solve this problem. In case you still have any doubts or you did not understand some part of this problem, do mention in the comment section and I'll try to solve all your doubts. So I'll be soon back with another video. Till then, stay safe, keep learning. Thank you.